Good morning. Come on, guys, it's day one. Good morning. Bonjour. Buongiorno. Ohayo gozaimasu. Buenos días. Guten Morgen. And G'day is for our Australian friends. So good morning, everyone, and welcome to the AEC Excellence Awards. Today, it's our 8th Excellence Awards, and I'm sure it's going to be the best ever. It's my favorite event at Autodesk, and especially at Autodesk University, because we get to celebrate all the work that you do. We get to celebrate all the innovation that you drive within your companies. And today, we are going to give 11 awards to all of you, or some of you. And we are going to do 3 things. The first thing we will be doing is reward and honor and celebrate your work. And we're going to give 9 awards for the AEC Excellence Awards. And they're going to be organized by size, so small, medium, large, and then building design, infrastructure design, and finally construction. So the last one will be construction. That's the first one. The second one will be about celebrating the Innovator of the Year. And this award will go to one specific person. And this person drive innovation and process change within his or her company. And this winner has been selected among close to 40 different nominees. The third thing we will be doing is about a new award that we are introducing this year. And it's about the Future of Making Award. And in this case, we want to celebrate a company. And this company has been driving automation and driving new technology and innovated in the world of AEC. And that's a new award that we will celebrate as well. But before we get started, I'm going to introduce you the Master of Ceremony, Kyle Bernhardt. I've been working with Kyle for about 13 years since he joined Autodesk. And Kyle was a product manager on Revit MEP. Anybody use Revit MEP? Raise your hand. Anybody? I hope you like the product. And Kyle also worked for a while on BIM 360 design, which is also a great product. And I work with many product managers at Autodesk. And the one thing I tell product managers is fall in love with your customers. Don't fall in love with your products. And I think you will see with Kyle's passion that Kyle is the true incarnation of that. So please welcome on stage Kyle Bernhardt.
Oh. Oops. Oh, one too many. There we go. Hey, good morning, everybody. Just like Nicolas said, welcome, first day at Autodesk University 2019. So I'm so thrilled to be here to celebrate some of the most courageous use of technology in AEC in the entire world. This morning, we celebrate your work, your achievements, and your innovation. And that innovation would not be possible without Autodesk technology. And we're so happy that you have chosen us as your technology partner in that pursuit of excellence. We learn so much from you every day. It helps us build it better for you. But before we get started, I gotta make it a bit of an admission to everybody. I gotta be honest with you guys. So as Nicola mentioned, my name is Kyle Bernhardt, and I'm a huge BIM nerd. It's not something I tell everybody, but it comes out from time to time. I've really gotten kind of hooked on the rush of kind of a late night binge, authoring project parameters in Revit to drive the materials of my family types and categories, or I kind of wake up in the morning at 5:30 and I remember exactly the right tweak to my view template settings to make sure that my custom visibility graphics are set for my linked models. This is all from real stuff that I do. But I take it from day to day, to be honest with you guys. Sometimes I fall back into my old ways, like the time I laser scanned my house so I could get an as-built BIM going for my kitchen remodel. or the time I decided to do a custom backsplash. So every single one of those was placed manually in Revit by my wife and I. I taught my wife how to use Revit. She hated it. It was fun. We did that in BIM 360 design. And so my contractor definitely thought I was crazy when I handed him a URL in BIM 360 to actually place each one of those things manually. But what we learned, and what I think these awards will tell you all, is that some time invested to author the construction intent of your design digitally helps to make sure the end result is what you want, and that is perfection. With, I guess, one small detail here, and that is that I forgot to include my kids' dirty dishes in the LOD 400 BIM that I created. So I'm going to need to put that in the punch list in BIM 360 for my next update, and probably spend about 8 or 9, 10 cloud credits to re-render the whole scene. But if you like my work, I got to be honest with you guys, because I've been working with Nicola for like 13 years, as he mentioned, and I'm always open to new opportunities, so call me. But enough about that and my love of being a BIM nerd. We're here to celebrate some real excellence that goes well beyond a residential kitchen of an Autodesk employee. I take it every day, I swear. But let's get into our first winner here. So we're going to start in the infrastructure segment, as Nicola mentioned. So let's switch over here. So as a parent of 3 kids, I have a special affinity for well-placed service centers on a highway, because my kids need to go to the bathroom all the time. And that's exactly what our first winner did, is they used digital technology to help lay out an entire highway line. So let's welcome to the stage the winner of our first award, so a small infrastructure project, engineering of the, and apologies, my Mandarin's terrible, so I got a little cue here, engineering of the Lushuan service area of Yulin, Zhenjiang Expressway. So please welcome up Tanjim Port Engineering Design and Consulting Company and CCC First Harbor Engineering Company. Welcome to the stage. Okay, so. Congratulations. And let me get you, are you going to speak for this? What's up? You're going to watch the video. Okay, thank you. Yes. You're going to speak on behalf.
Unfortunately, the customer cannot be here today. They have a video for the project. Please enjoy. Thank you.
BIM application in engineering of Luchuan service area of Yulin Zhenjiang Expressway. Completed by Tianjin Port Engineering Design and Consulting Company, which belongs to China Communications Construction Group, one of the top 500 companies in the world. Located in Luchuan County, Yulin, Guangxi Province, the project is being constructed through PPP application. When starting the project, we were facing many challenges, including BIM tap-down design, information transfer in PPP project, optimization of traffic flow organization, optimization of evacuation plan, green building analysis, and assisting decision-making in operation and maintenance. To deal with those challenges, many solutions have been proposed. Autodesk software series are adopted for BIM modeling and application in this project. The universality of Autodesk software makes the application of BIM model unimpeded. Meanwhile, multidisciplinary and multi-participant collaboration design is carried out. After the completion of the design work, BIM model is established and analyzed, which consists of site analysis, analysis simulation of traffic flow, simulation of evacuation, solar radiation analysis, outdoor wind environmental analysis, indoor energy consumption analysis. And then with the help of BIM technology, drawing preparation and quantity calculation are automatically generated. By applying BIM, we have reaped lots of benefits. The design efficiency is improved. The information is effectively transmitted in the whole life cycle. The simulation assists the operation and maintenance management. The building performance analysis provides statistics for energy conservation design. BIM Cloud collaboration makes communication between teams more convenient and efficient. To conclude, we wish the ceremony and the conference a great success. Thank you.
Pretty cool video. So the next one is going to blow you away. Sometimes even the simplest of innovations can be game changers. Our next reward recipient saved an incredible amount of time and money just by going paperless. So please join me in welcoming to the stage the winner of the Small Building Design Project, the revitalization for design, construction, and operations of pre-World War buildings for Urban Renewal and Authority and AECom. Welcome to the stage.
Okay, hi. Morning, everybody. This is Thompson Lai from AECom Hong Kong. This is my great honor to present the award project on behalf of my client, Urban Renewal Authority and AECom. Our project is revitalization for design, construction, and operations of pre-World War buildings. The building you can see on the screen are actually built in between 1920 to 1964. Urban Renewal Authority has a vision that we don't only apply our digital technology and BIM in design and construction stage, but they know that the digital technology has to be applied to also on operation and maintenance stage, which is very long-lasting. So you can see we apply this to both of the stages. Let me dive a little bit deeper to what we have been using BIM and digital technology for our project. First of all, BIM is the overall project management tool, and it involves across multiple phases of the project lifecycle. It is also a collaboration platform between multiple disciplinary project stakeholders. We also create an innovative, integrated platform for BIM and FM dashboard for our stakeholders. And the system architecture is actually cloud-based. It's flexible enough for our future expansion. This is a simplified system architecture for your reference. As you can see, we make use of Autodesk Forge as an integration platform, connecting as-built BIM models, connecting all the BMS sensors, IoT sensors, and a flexibility management system, which is IBM Maximo, to provide an integrated BIM-enabled FM platform for our project stakeholders. So this is some sneak peek of our project. Of the screen layout. This is the first page of our project. Project stakeholders can make use of this dashboard to navigate to every single project within the platform easily within the map click. And this is a 3D dashboard viewer, which is a highlight for the project. We will have all the real-time equipment information showing on this 3D viewers, which is a Forge viewer. And then we have all the real-time information pop up to show you what is the status of the equipment. And this is a 2D, very important one, because the property manager always makes use of this dashboard to see all the equipment status, works order status, and also the live CCTV stream video. So to conclude my presentation, I'd like to share with you my project video. So this is the old days. Actually, we have a lot of historical stuff like the columns we have to preserve. And this is an early stage adoption within design and construction stage of BIM technology. And we also did a lot of analysis like the solar analysis, shadow analysis, and of course, clash analysis and drawing production. And it becomes to the integrated platform on the cloud with Forge Viewer. Yeah, this is a very congested area within Hong Kong. So this is a video viewer that I mentioned to you with all the real-time information pop-up. The live CCTV feed and the dashboard information. And also we can create works order according to the equipment status. Whenever there's any problem, that we can create a works order on this 3D dashboard. Because we can search all the information that within the BIM models. This is a prehistorical column that we have to preserve. So this is a asset history with all the menu connected to the system. The frontline staff can review all the information easily within a few clicks on the viewer. And we also connect to all the BMS sensors that we can connect and control the lighting, air conditioning, and all the BMS-enabled sensor equipment. Toilet is one of the very important things that we have to monitor because it's a public accessible buildings. So this is what we have prepared for the last year, the project. And the system will be available by end of this month together with the buildings. But this is just the start of our smart building journey because there will be a lot of buildings joining the platform in the near futures. Thank you. Thank you again, and thank you Autodesk for the award. Thank you.
That was a great illustration of how investing in Forge and the Autodesk ecosystem can help you do great things. So for our next winner, you'll see how modular construction can help a project work like clockwork. The project team took an advanced tech-first approach that used drone mapping, laser scanning, 4D planning, and mixed reality. They did it all in my backyard of Beverly, Massachusetts. So please welcome to the stage Windover Construction for the Small Construction Size Project Award for Canvas. Welcome to the stage.
Good morning, everyone. I'm honored to be with you all today to present about our project at Canvas in Beverly, Mass. So, Windover has been a leader in modular construction. this project is 184 boxes that got placed for 2 buildings. Building A, as you see down there, the U shape, and building B, the smaller one. So what we did is that we placed all the boxes virtually first before we put them on site to make sure there are no surprises on site. So the challenge for this project was that we have, as you see here, this is an aerial view, this is building A and building B on the other side. The challenge we had on that project was that we have a steel structure podium on the first 2 floors holding up the 6 upper floors that are modular construction. So we have 2 different systems, structural systems, that needs to be in harmony together, very well coordinated. The first 2 floors are coordinated through the regular plumbing system with pipes going up through the vertical curves, and the upper floors are made in a controlled factory setting, in a factory to control quality and to get the boxes ready in the factory. So what we did is that we made sure to coordinate everything by capturing on-site as-built steel. So we are not coordinating with drawings for the steel. We are coordinating actually with the as-built steel on site. So every time we had the steel structure erected on site on 6 phases, we go fly the drone with controlled survey points on the ground. And also we capture, so the drone captures the aerial view of the steel, as-built steel, and we supplement that with scanning on the ground to capture whatever the drone didn't capture. And then we combined both in VCAP Pro, both point clouds to have an accurate representation of the as-built steel on site. Then we took that further and modeled in Revit all the MEBs for the lower part and the upper part. And we communicated after each flight on 6 flights in 2 months phase meetings with the factory that's making the boxes. When we overlaid, what you see over there here in red is where the factory was planning to put their vertical shafts. And we were able to overlay that in real time with what we captured on site to help detect the conflicts early in the process. And we made sure when we placed those boxes that everything fits perfectly, from the lower part that was built on site and the upper parts that's built in the factory. Another way, another innovative way, that we use the Civil 3D to help get the spot elevations for the facade. When we place those boxes, sometimes the facade is not very smooth. So in real time, we're able to communicate to the facade team the strapping thickness through laser scanning the facade using a laser scan with its accuracy every 70 meters, only 3 millimeters off. And then we were able in Civil 3D to detect the spot elevations here. So we communicate that in real time and they end up with a high quality, preserving the design intent for the facade. Very smooth. We also used on that project a blank grid. Our super, Dustin, our great super for the project, loves blank grid because it helps with collaboration on site. And it really helps with real-time communication. So that was our project. And that wouldn't be made possible really without mastering all the Autodesk softwares and all the great options we have. We used CAD for early drafting. We used the Recap Pro for combining drone mapping and laser scanning to have an accurate representation of what the site is. And combining drone maps with laser scans from below with different tolerances. That was really amazing to have these together. Navisworks for MEB coordination. Civil 3D for the spot elevations and for the handling the contour maps and contour lines we capture from the drone. For early excavation work, monitoring, and keeping track of construction progress. 3D Studio Max for animations and 4D and visualization. Revit for everything starts in Revit. When we build those 3D models, it's all in Revit. It's built these information-rich models. And of course, a blank grid. So thank you so much. And we are glad to be, modular construction is transforming the construction industry. It's making it greener and more efficient. And what Wendover is doing is that we are transforming the modular construction planning to help it build better and safer. Thank you so much.
That was really cool. I love modular design. It's really obvious that that's going to be part of that future of making, something that we talk so much about here at Autodesk University. And so let's switch to our next project, which reminds me of one of my lifelong battles, which has been starting in the 4th grade and moving till right now, the battle to deliver the coolest virtual city. And so my latest one is a video game called City Skylines. If you like city builders, it's a great one. And so I placed every one of those things manually. It was really cool, but it was nowhere near as cool as our next winner, which did this in the real world. So they designed a 16-kilometer rail line, and it had to connect to 5 existing metro lines. So some of this virtual, but in a very real world. So congratulations to the winner of our Medium Infrastructure Design Award, the Istanbul Rail System Services Phase 1 by Yüksel Proje, Istanbul Metropolitan Municipality. Congratulations.
Hello, everyone. First of all, on behalf of my team, I would like to thank to Autodesk for organizing such a beautiful event, and to the grand jury for seeing us worthy for this award. My name is Aslı Şahin Akyol. I am an architect, and I'm working as the manager of the Rail System Design Directorate at Istanbul Metropolitan Municipality. As the head of the project's owner team, I would like to briefly explain our project, Istanbul Rail System Design Services Phase 1, focusing on the contribution of Autodesk solutions. I strongly believe that to understand the project, you have to understand the dynamics of Istanbul. Istanbul is known as the cultural and economic capital of Turkey, a bridge between Asia and Europe. The city not only has a valuable historic urban fabric, but also offers its inhabitants and visitors a 24-hour progressive, fast-paced contemporary lifestyle. Like many crowded cities, like many crowded metropolitan cities around the world, Istanbul faces problems in traffic congestions and environmental pollutions. As the Istanbul Metropolitan Municipality, we are working with dedication to solve these problems. The Istanbul Metropolitan Municipality is committed to develop a high-tech public transport network by the implementation of innovative and sustainable solutions. With this motivation, the railway system in Istanbul will reach approximately 450 kilometers within 5 years. Istanbul Rail System Design Services plays a vital role to achieve this goal. It involves the design of different rail systems lines with a total length of 60 kilometers. Phase 1 involves the construction of a 16-kilometer metro line. It will comprise of 11 stations, also integrating to 5 existing metro lines. The project includes the collaboration of different entities, development of feasible solutions, implementation of operational and maintenance activities, while increasing technological knowledge. Most importantly, we reached our highest level of work through integration of all of these aspects and experience at the beginning of the design. Our main objectives were smart transportation leading to smart cities, sustainability, building information modeling and innovation, 12 different disciplines, multiple locations, 100+ models, and 20 Autodesk tools, and the result is, let's have a see. Such a nice film, isn't it? Not everyone is with us today. I would like to thank my friends who participated in this project, my colleagues at Istanbul Metropolitan Municipality, and the designers from Yüksel Proje, as you see. Also, I would like to take this opportunity to thank Autodesk Turkey, Özgür İleri and Niyazi Kemer, especially for their encouragement and support. I strongly believe that we have achieved this success as a team. Thank you very much.
Leave it there. You can leave that there. Okay, cool. Thank you. Awesome. I'm gonna leave it here. Cool. So I couldn't help but notice BIM 360 design and specifically design collaboration in that video. That's awesome. On behalf of the team that I worked with to help build that, it's great to see that being used out in the real world. So let's switch gears here a little bit and let's think to the times we've worked with owners. And I don't know if anybody in the audience can remember a time that an owner asked for 3 months extra time on their project. Can anybody think of a case where your owner said, I want my project to take longer? Yeah, I can't think of it either. And this next project actually shaved 3 months off the overall schedule time. So let's get right to it. So the winner of our medium-sized building project is the East Artificial Islands of Hong Kong Zhuhai Macau Bridge. And that's done by the CCC FHDI Engineering Company. Congratulations, welcome to the stage.
Unfortunately, the customer cannot be here today, but they have a great video to show their project. So let's see it.
So I'm going to make up an award on the spot. So the winner for most epic background music of any video goes to those folks. That was like a Jerry Bruckheimer movie. That was awesome. I love that. Job site health is one of the most important aspects of any project, no matter what the size. So in this next winner, they showed how a safe project can help deliver a better end result. So let's welcome to the stage the winner of our medium-sized construction project. So E03 Canada Court, E05 Quebec, Wembley Parkby, John Sisk and Son. Welcome to the stage. Congratulations.
At John Sisk, we live in a world of zero. Our philosophy for every project is zero incidents and zero injuries. And with that, we aim for zero defects, zero snags, and zero delays. Essentially, zero surprises. My name is Darren Noonan, and I'm a project manager on the EO3 Wembley Park development.
And I'm Dave Vater, the BIM engineer for EO3. Today we'll be discussing the innovative way we are handling information on our project and the positive metrics we have achieving to date.
At John Sisk, we are an international construction company, founded in Ireland, now working across Ireland, the UK, and mainland Europe. We place a strong emphasis on performance, quality, teamwork, and a hands-on management approach to ensure client satisfaction. It is a family-run company founded in 1859, with the family still directly involved with the business today. This has helped us maintain the attitude for building excellence over 150 years by building trust, certainty, and value for our clients. We are currently involved with a number of projects throughout Ireland, the UK, and Europe, stretching across multiple sectors. Today we'll be focusing on one of our most innovative projects, Canada Gardens, at the heart of the Wembley Park regeneration scheme. So the project today, Wembley is located in northwest London, with the new regeneration scheme centred around the world-famous Wembley Stadium, as sure you're well familiar with. So we've been closely involved with the Wembley development for over 14 years, building a close relationship with the developer and the wider Wembley Park team. To date, we've completed 7 projects, which include 1,000 residential units, 350 Hilton hotel rooms, 660 student accommodation units, a shopping outlet, and a multi-storey car park. Currently, we have 2 live projects with a total build cost of £425 million. Our ongoing projects within Wembley Park are 2 high-rise residential developments. These are set to provide an additional 1,200 residential units to the area. Today we'll be focusing on the larger development, EO3 Canada Gardens, where we ran our trial using BIM 360 to create a set of digital smart containers. The project itself is 743 PRS apartments spread across 7 different buildings. It's got a landscape podium, an energy centre to provide district heating to the whole area, a coach park which will have the capacity for 81 coaches on an event day.
Right, data is new oil. It's only useful when it's refined. The main challenges we faced came down to the efficient refinement, access, and sharing of information throughout the site. These challenges included getting information to operatives on site with relative speed and ease, the lack of live information available, no access to 3D information on site, ensuring all the information is accessible within one platform, and limitations with communication between project sectors. Drawing from our philosophy, our goal was to ensure the management of this information created zero inefficiencies throughout the life cycle of the project. We accomplished this by utilizing the capability of BIM 360 Field to create the aforementioned digital smart containers. By hosting these within BIM 360, we can access all relevant data by scanning a QR code associated to a flat or material container, giving our team access to the latest information relevant to their location on site, along with access to live tracking and dashboards of materials and spaces. To effectively manage this new process, we developed a cloud-based API with support from Autodesk to link all the data from our CDE to BIM 360 automatically and provided all of our site operatives with digital tablets. Shown here is an example of our live project dashboard, where all the information from site can be summarized into easy-to-view infographics and filtered to whatever level of data you require. From the implementation of these new processes and workflows, we were able to achieve a 35% time saving whilst conducting our QA/QC process versus traditional methods. This saved an average of almost 14 hours a week per user, freeing them up to perform more high-value tasks and ultimately enabling them to go home and spend value time with their loved ones. We are currently in the process of handing over another block from EO3, and we are 4 weeks ahead of schedule. We at CISC are also committed to the principle of sustainability. The use of BIM 360 has made it possible to reduce the paper usage on site by a massive 44%, around 19,000 A3 pages a year, contributing to a yearly reduction of CO2 of almost 150 kilos. This has also made us the first CISC project where the snagging process is 100% digital. Using the live project dashboards to display the information from BIM 360 has increased project management efficiency by 15%. All of the information is in one easy-to-navigate place, eliminating the time taken searching for and updating trackers and spending meetings updating the project team. There is one source of truth for all project information. Finally, we have achieved an overall production efficiency of 21%, as shown in the table below. Our subcontractors are steadily becoming comfortable with the new system, and in the first 5 months' time to close any issues in the project, and in the first 5 months at the time to close any issues in the project fell from 20 days to 30, and we are well on course to hit our 35% reduction by the end of 2019. Thank you for listening. On behalf of John CISC, thank you for this award.
So if my hometown Boston showed the world what happens when you poorly plan an infrastructure project in the digital realm, so these guys are doing the exact opposite. So let's join me in welcoming to the stage the winner of our large infrastructure project, the Umrania Ataşehir Göztepe Metro Line, and that is delivered by the Gularmak Nurol Makyol joint venture. Welcome to the stage.
Thank you very much for the award. This award will be a great incentive for our further BIM studies. My name is Gökhan Arkuş. I'm the project manager of Ümraniye Ataşehir Göztepe Metro Line, undertaken by the joint venture formed by major contracting companies of Turkey, Gülarmak, Nurol, and Makyol. Our client is Istanbul Metropolitan Municipality, and the designer is Yüksel Proje. Our line is about 13 kilometers long with 11 stations and a depot for maintenance and stabilizing of the metro trains. Mainline tunnels will be bored by 4 EPP type TBMs, and station tunnels will be bored with conventional tunneling method. This is a turnkey project which consists of design, construction, finishing works, track works, electromechanical works, signaling, and commissioning of the line. Istanbul is one of the most crowded cities in the world, with around 20 million population. Like other populated cities, one of the biggest problems in Istanbul is traffic. Daily movement is about 13 million, and 25% of this movement is carried by metro systems. This is a figure to be increased. Our line will play an important role to increase capacity of rail transit system in Istanbul due to its special location. Current metro lines, shown in red color, are located in east and west direction, and our line shown in blue color, is designed in north and south direction. Therefore, our line will have intersection with 4 lines, 4 metro lines at the same time, and will have a big contribution to establish a metro network in Asian side of Istanbul. Capacity of the line is 44,000 passengers per hour per direction, and total daily expected passenger is about 500,000. As may be expected from a large-scale metro project to be implemented in Istanbul conditions, our project contains many challenges. Some of these challenges are as follows. North and south sides of the line are passing under mostly populated residential areas, and middle section is near to finance and business centers. Tunnels to be bored in the project will pass under approximately 1,600 buildings. Due to dense placement of the existing buildings, only available places for construction are existing roads and limited spaces between buildings, which is a big challenge for construction. There are also some historical buildings like mosques and station buildings under effect area of the tunnels, where special care to be taken during tunneling. BIM technology helped us to overcome mentioned challenges effectively. Autodesk solutions made every step easier for us to implement BIM uses. Using related softwares, 3D information models were created. Interdisciplinary coordination was provided by using these information models. These models helped us to overcome overspending and time loss during construction phase and design phase. Construction and site utilization plan was made by using 4D simulations. Since headquarters of the contractor and the designer are in different cities, cloud solutions played an important role for collaboration and coordination of the companies. At the end of this process, it was clearly seen in design stage that BIM technology provides cost saving, and it is also avoiding time loss. Errors and repetitive works were minimized, and collaboration and coordination were maximized between stakeholders. Thank you very much again for this beautiful award and this great organization. And this will be a great contribution for our BIM perspective. Thank you very much.
So a common thing we've heard throughout all of these winners has been collaboration. And so our next winner is that to the next level. There were 13 different member countries as stakeholders that were involved in this project. And it actually reminds me a little bit of a project I did with my fabricator. We designed in Revit a shed, and then we built it in a prefabricated way. My crew, which was my kids, they helped really well on this one. It was fun. We're very happy with the end results. And so, again, just a reminder, I'm open for any feedback. You just feel free to reach out to me because, this is really cool stuff. But enough of that. Let's jump to the next winner here. So our winner here for the large building project is the European Spallation Source. That is by AF Infrastructure, Sweco Architects, and Skanska Sweden. Welcome to the stage. Congratulations.
Right. Good morning and good morning till all the Swedish guys in the audience. Thank you very much for this award. We've been working very hard since 2015 implementing BIM in this project. We and our design team back in Sweden. So this is a great achievement for us and also a good recognition that we have succeeded to hold this high standard throughout the project. So we'll now show you a video of what we've been doing in these years.
The European Spallation Source is a multidisciplinary research facility based on the world's most powerful neutron source. ESS is one of the largest building projects in Europe, with a budget of more than $1.8 billion. Once done, it will be the world's most advanced and first sustainable neutron research facility.
Autodesk technology established a fundamental basis for the facility design and construction. It was decided early on that this project will be a Revit project. A clear majority of the designers work in Revit, and subsequently, the collaboration is made simple through just that fact alone. We have to work closely with what we call a Revit base file. This is a master file that contains everything that the designers need to deliver according to the requirements of the project. We have used Dynamo with Revit to enhance and streamline processes both for our work, but also created scripts for the designers to use and enhance their productivity. This process has enabled us to optimize time in several areas of the project.
For collaboration, we have regular coordination meetings with the designers and stakeholders. Navisworks Manage have been the main tool for clash detection and design review during the design and construction phase. In the project, we have worked with information chains. We use the same models throughout the process for design, calculation, purchasing, planning, production, adaptation, construction, and for the facility management. We have also developed software and processes that help us with the review of models, documents, and drawings.
3D Max and Unreal Engine have been used for visualizations, movies, and virtual reality. Utilizing Navisworks combined with 3D Studio Max and Unreal Engine enable us to import stable models in virtual reality, which were used in the project as a tool for collaboration. Together with the client, we have explored and designed the future work environment inside virtual reality. Virtual reality was also used for reviewing the design to optimize the maintenance in the future and to be able to see where equipment best could be placed.
Using camera 3D tracking with a drone enabled us to visualize the 3D model designs and actual surroundings many years prior to completion. Rendered contents from 3ds Max proved beneficial regarding the communications between design, contractors, stakeholders, and board of directors. With camera 3D content, we can provide enhanced experience with what the end result will be, further increasing the understanding between many teams within the organization as well as externally. With photogrammetry, we have enabled building inspections by using 3D scanned buildings generated from Autodesk Recap Pro, cross-referenced with the as-built models from Revit and Navisworks. High-resolution footage generated from the drone was also reviewed for further quality control.
The European Spallation Source is an extremely unique project that will impact the world in ways that we can't even begin to fathom.
The construction process implemented by Skanska, for example, regarding environmental requirements in a project of this magnitude is a win for the planet and a great example for what can be done in every construction site around the world.
The BIM in this project has had its challenges, but we have managed to implement our thoughts and ideas, work through our challenges together as a team, and we are proud of the work and effort we have put in.
Working on this project for such a long amount of time, you learn a lot about yourself and the people around you. We've all grown and expanded our skill sets along the way. We started this as strangers, and we'll finish it as friends. Thank you.
Thank you.
Thank you.
Thank you.
Thank you.
Hey, thank you. So I'm going to start the next one here with an awesome joke. So where do basketball players like to go to eat? Dunkin' Donuts. Yeah, there we go. That's what I'm talking about. Thanks, guys. Awesome. So our next winner is going to show us how they built a new home for the U.S. NBA champion Golden State Warriors. They did it in a very complex location that also is very close to Autodesk's backyard in San Francisco, California. So please join me in congratulating the winner of the large-size construction project, Chase Center and Warriors Mixed-Use Office and Retail Development, and that was done by Mortensen Clark, a joint venture. Come on up.
So we're going to start with a video of the project. So today we're going to be talking about automating the mundane. I'm Santino, this is Lucas. So I'm a Texas native, went to school at SciArt. Lucas is a Pennsylvania native and a Penn State alumnus. So Chase Center is a sports and entertainment venue that serves as home court to the 6-time NBA champion Golden State Warriors and as a backdrop to nearly 200 events annually, including Warriors basketball, concerts, family shows, community events, and more. The state-of-the-art 18,000-seat arena anchors a site that also includes 2 11-story office buildings, an iconic broadcast studio, over 20 unique retail locations, 3.2 acres of plazas and open space, as well as a below-grade parking structure.
Thanks, Santino. So now that you've seen how it kind of all came together, I wanted to take a moment to just dive into 2 of kind of high-level things that we did that is accessible to really any project. So to bring you into San Francisco, it's an 11-acre site on the south side of San Francisco, California, in the Mission Bay district. There's about 3,000 linear feet of perimeter and soil excavation that equated to 737 unique soil tieback systems. This allowed us to excavate 28 feet down below the San Francisco Bay, as you can see there, and remove over 350,000 cubic yards of soil. So let's rewind a little bit back to these tiebacks. So with 737 tiebacks, all governed by excavation depth and foundation type and soil type and all that, equated to almost 10,000 unique parameters. And yes, those did change multiple times throughout the course of design and construction. But why go through the process of trying to coordinate something like that? Well, unlike other areas in San Francisco, Mission Bay neighborhood didn't have the site infrastructure needed to support an 18,000-seat arena. So with the help of Dynamo, we were able to generate those 737 tiebacks in less than 3.5 minutes. That's 3.6 tiebacks per second that allowed us to coordinate with site infrastructure that wouldn't be installed for months to come. Keeping on that theme, we're taking information readily available to the project team and aggregating it and implementing it in ways otherwise not used. Our precast stadia pieces, which is key to any stadium or arena, was part of the critical delivery of this project. We took information being tracked by our trade partner, Clark Pacific, and implement that in a way to build dashboards and communicate to key stakeholders when those pieces were fabricated, ready to ship, and even installed, because it was installed on night shift. This, while building nice dashboards, also built out what we called print maps that we can communicate key stakeholders in a more physical way. These are just 2 high-level examples of just some of the mundane things that we use the Autodesk suite to automate, coordinate, and collaborate on.
So we just like to thank our partners who we worked with. Of course, the Golden State Warriors, architects, Kendall Heaton Associates, and then we also are project engineers, Walter P. Moore, MKA Smith Seckman, and then of course, Mortensen Clark joint venture. And of course, a project like this necessitates a great team as well, so there's tons of firms involved. These are just a few, there are many more. So thank you, go Warriors.
All right, so it looks like Kyle is looking for a new job, or maybe he's asking me for a big bonus for what he did today, so we'll see. All right, so we have 2 more awards to go, but before I do that, I would like first to thank all participants for all of the submissions, and we got hundreds of submissions. And I would like to also thank the winners and congratulate them, because they are doing amazing work today. So let's give them a big round of applause. And then the next thing I'd like to do, I would like also to thank our judges, because they had to go through a lot of different projects and submissions, and it was a lot of hard work. So please, thanks all of the judges. And finally, the sponsors that we had for this presentation. So another big round of applause for all of our sponsors. Thank you. All right, so the next award, and we have 2 to go, is the Innovator of the Year. And this award goes to somebody that drove change and innovation within his companies. And in this case, the person I'm going to bring, I think you all know this person. So please welcome Amar Rafat. He's the Vice President of virtual design and construction and technology at Windover Construction. And he's going to tell us about it. Thank you. Thank you.
Hello. It's a great honor to be with all of you today. It's been a journey of hard work, dedication, and persistence to learn almost every 6 months new technology and new ways to help build better and safer for our company and also to do unprecedented work for the industry. Learning about laser scanning, drone mapping, virtual reality, and augmented reality, 4D animations, sequences. Mixing technologies together. So someone would think that we are as good and accurate as the equipment we have and the technology we have right now. I think that's not very accurate. I think we are as good and accurate as the imagination and the innovation we can bring every day on our job sites and on daily basis. We can use today's technology with tomorrow's vision to help our job sites be better. The first thing I do is I've been always listening to our job sites and our teams about their challenges, learn more about the challenge, and find ways to respond with a solution in real time that could make the job site safer and leaner in terms of construction processes. Also, we have all these different technologies that we are blessed to have today. And the best thing we can do is to mesh them together. What I've been doing is that I worked on mastering all these different technologies. And then the best thing you can do is to mesh them together, make them work in harmony together. It's not always working. Sometimes it doesn't work, but needs persistent and hard work to make it work. Try things, might not work, try again. And then to help with mixing drone mapping with laser scanning, for example, and work within the software to make it all work with tolerance and accuracy. Safety is a big thing on construction. It is the most important thing in construction right now. And I think VR, what we developed for VR safety training, I've been working with 3D Studio Max to create VR immersive experiences to train our site teams to help them learn more about safety and practice it in VR without even having to leave their trailer office. Mixing the VR with drone mapping to offer light study solutions for different projects. Even after projects are done, we can still support our clients with VR and safety or with drone mapping. Mixing reality on site, overlaying 3D models, having this immersive experience for our clients and for our job site teams to really help offer real-time solutions and manage change of materials and change of design in real time. Combining all the data in terms of laser scanning and drone mapping for BIM coordination. That's all to support building safer and quicker and faster. And that's all is only possible when you work in an environment that lets you really focus on what really matters to be innovative. And I thank Windover Construction for believing in me, for embracing new technologies. All the job sites, when I go to talk to supers about the new technology we're going to apply on the job site, they get excited, embrace new technology, we can try new things together. So I thank them for this culture of embracing new technologies and being open for it. And thank you so much. Thanks, Autodesk, and thank you. It's a great honor to be with you, and it really encourages me to do more work for our company and for the industry to be more innovative, for us all to help build safer and more efficient and greener. And this is a future, and thank you so much.
We're going to take pictures. Let's do pictures.
Thank you so much.
Thank you. All right, we have one award to give away, and I'm really fortunate. I've been working with this company in Japan for over 12 years. It's a large company, and just a few years ago, I was lucky to visit one of their labs, and what I saw just blown me away. Actually, you can see me here with the winner. And this company has been researching and developing really interesting technology that will advance the industry. And that's why this award was created to recognize their work. So please welcome Mr. Masahiro Indo from Shimizu Corporation. Questions? I'm going to ask a few questions to Indo-san here. So welcome, my friend.
Yes.
And it's really exciting to have you here, so please sit.
Yes, thank you.
And to have you at AU, we met a few times in Japan this year and last year.
Yeah.
So, please tell us more about Shimizu and about yourself.
Yes, I come from Shimizu Corporation. I just introduced my company. Our company established from 1804, 200 years more. And left-hand side, the guy is our founder, Kisuke Shimizu. He looks like a samurai, but he's actually the master carpenter. Also a builder and a designer. So we have a design office internally, also an institute. Last year, the sales was 14.3 billion US dollar, and 26th largest contractor in the world, and also with 10,700 employees. Okay.
Thank you. What about yourself?
Myself, I'm Masahiro Indo. I'm very enthusiastic for the making things from childhood, making radio control car and airplane, and the audio amplifier. I work in Shimizu for 41 years, 26 years for the site control, management. And after that, I joined to the construction technology division to support all the technical issue for the site and also machinery and taking care of the beam modification and also developing robots. These photos show the most complicated project in my life.
Thank you. So you all know about autonomous cars, right? And then, some of the things we've been talking about is, how can we use autonomous machines on construction? And when I was in Japan and saw Shimizu last year, I was really amazed with the work that you did with the robots. So can you tell us more about these autonomous robots you've been working on?
Okay. This is the ratio of the worker last 10 years. We reduced the superstructure people by the ratio and increased the number of the ratio external finish and M&E and finishing work. We discussed about the robotics with the site people, subcontractor, and the managers many times. Which one to be replaced by the robot? So we confirm physical work, transportation work by robot, and the rough work for the welding. and the manual work for the finishing and the M&D work. Back. Before I go to the robot, I have to explain about the RoboMaster Cloud. Once the site manager is locked by the iPad, the RoboMaster Cloud starts to move the multi-robot together. This RoboMaster Cloud can control more than 8,000 robots with 100 sites in Japan or in the world. Finally, we conclude to make these three kinds of robots, as I say. One is robot carrier for transportation. One is robot welder for welding. The third one is a manual work, robot body. All these robots can move themselves, look and sense themselves, and think themselves, and cooperate each other under the RoboMaster Cloud. And also work like a body and reliable. We try to make these one for the human-friendly design. Let me introduce by the video. Left side is a labor carrying the 1-ton material. 2 workers at the ground floor, 4 workers working at the upper floor. This is a very dangerous work. If we do this one by the robot carrier, by the one supervisor, command by the iPad, the ground robot carrier carries the material to the elevator. This autonomous elevator lifts up to the upper floor. Another robot carrier waiting at the upper floor. 2 together at the one stage. Another one waiting at the upper floor, taking out and deliver to the actual position to install in the nighttime. Another one is a robot welder. The left side is a traditional way to welding. He has to keep the position in the same speed and the very accurate position. If the robot welder scan the position before he starts, and also clean up the head before he starts. He will think how to weld and all the pass simulation. Every pass finish, he scan again and adjust the way of the welding again, and he will continue this one until finish. The third one robot is a multi-skill robot body. The center one I explained. The seating board installer, the human the guy lift up the board, supported by his head and his left hand, take out the screw from his mouth, and fix it. But he has pain in the neck and back. By the robot body, he scanned the edge of the board and fixed the subframe by the other hand. And the importance is after he installed one plate, they shift to the next position with the cooperation of the assist robot, go together under the control of RoboMaster Cloud.
All right.
Okay.
Isn't it cool? Yeah, please give a big round of applause.
Thank you so much.
I love it. And what you see here is still in the labs, but I was lucky to see deployed on the construction site. So it's something that's happening for real. So what's next? Where are you taking technology?
We use already 10 number of the robot this year, and we are it's very efficient and a good reputation in the site. Every people scare the robot how they work, take the risk. But after they use, they are very much appreciate to the robots. So we are going to increase the number of the robots. The next year, 2020, we are going to apply 20 numbers of robots. This is our policy of smart site. Consists of field work and intelligent work for the management and the structural work for the design of the structure and the material. Under the control, under the database of BIM, also database of the RoboMaster Cloud. And my conclusion is these robots are 3 processes out of thousands of processes, and only the platform. We are going to apply the deep learning to improve these robots by the data collection, and develop and application by open innovation. The most important thing is these robots are made for the people to be happy. More wage, more holiday, more comfortable condition, and more safety. And the wider the range of the diversity of the workers. Thank you.
Thank you. Thank you. And thanks
Thank you so much.
Let's give him a big round of applause. So we are going to close now this session, and Indo-san, you can stay with me here. I would like to thank everybody for the submissions, congratulate again all the winners for your awards, and better starts here at Autodesk University, so enjoy the conference, enjoy the classes, and I hope to see you next year, even more than today. Thank you.
Thank you so much. Thank you, Autodesk.
Yeah.
Thank you, everybody.
Thank you.